Imagine trying to blast like 18 gigabits of data per second through standard office wiring that spans, half a football field.
Yeah.
And doing that without dropping a single pixel.
Right. Or compromising even a fraction of color. It's
Yeah.
a massive challenge.
Exactly. And that is the exact mission we are unpacking today in our deep dive into the Kramer EXT3-H-R 4K 60 4.4 HDR HDMI receiver.
I mean, I know it definitely sounds like an alphabet soup product name, but
Totally.
yeah, but those numbers are actually the exact blueprint for a major physical engineering feat, especially, that 4.4.4 part.
Okay, yeah, let's unpack this. Because for anyone listening who works in AV, you know that 4.4.4 means zero chroma subsampling. Every single pixel gets its own dedicated color data.
Right, there's no sharing.
No sharing, no shortcuts at all. Which is exactly why the data load hits that massive 18 gigabits per second. But, the core physical challenge here is that copper degrades high-frequency signals over distance. So how does this box push that much data 130 feet over just standard CPA cable without the signal just, completely falling apart?
Well, what's fascinating here is how HDBaseT 3.0 handles the actual physics of copper wire. Because in older standards, you really had to rely on compression to squeeze a 4K signal through that bottleneck.
Right, you had to crush the data down.
Exactly. But HDBaseT 3.0 uses an advanced modulation scheme. It's called PAM16. And instead of just sending standard binary ones and zeros, it actively varies the voltage across 16 different levels.
Ah, okay. So instead of a single light switch just turning on and off, it's acting like a highly calibrated dimmer switch?
Yes.
Like transmitting 16 different states of data all at once?
Yes.
So you're packing dramatically more data into the exact same frequency space.
Precisely. And that's how it achieves uncompressed 4K video at 60 hertz with, full HDR contrast over standard twisted pair copper and with near zero latency. Yeah, it's fundamentally altering the density of the transmission at the voltage level, which is how it maintains a pristine, completely uncompressed signal end to end.
Okay, but I have to push back here.
Yeah.
Because this is usually where the physics catch up with you.
Oh, the heat.
Yes. I know from setting up enterprise racks that doing that level of complex digital signal processing generates a massive thermal load.
Oh, absolutely.
And this isn't just video we're talking about. It's crunching 32 channels of uncompressed audio, plus embedding bidirectional RS-232 and IR control data.
It's doing a lot of heavy lifting.
Right. And normally you need active cooling, like a loud, heavy fan, to keep the processor from just melting into slag. Yet this Kramer unit is, a 4.7-inch, 0.6-pound block?
Yeah, it's tiny.
So how does it survive its own heat without sounding like a jet engine?
Well, if we connect this to the bigger picture of modern hardware design, the real engineering marvel is actually the chassis architecture itself.
Oh, really?
Yeah. Kramer uses what they call a Digitools aluminum enclosure. And it doesn't need a fan because the entire outer chassis is engineered to act as a highly efficient geometric heat sink.
Wait, so the microengineering routes the internal thermal loads directly into the outer casing.
Exactly.
And it just relies entirely on ambient convection cooling.
You got it. The heat dissipates naturally, which makes it dead silent. And in professional environments, acoustic noise is just as detrimental as visual latency.
Oh, for sure. Nobody wants a humming rack in a quiet boardroom.
Right. So by making it fanless and incredibly compact, you can just drop it directly into a ceiling or mount 3 of them side by side in a standard 1U rack space.
That's incredibly versatile.
It is.
Yeah.
And because they're often hidden away in, dark drop ceilings, Kramer engineered the local LED indicators to instantly show the link and power status. So you don't even need to hook up a monitor to troubleshoot.
Oh, nice. The diagnostics are immediately visible right on the ports. So what does this all mean for you, the listener? To me, it really highlights how accessible high-end enterprise engineering has actually become.
Yeah, it's a huge shift.
We're talking about uncompressed, zero-latency 4K architecture that runs dead silent. And it's not even gated behind massive corporate budgets anymore. Like, as a benchmark, we noticed HDTV Supply currently has this exact unit marked down from $470 to $376.
Which is a steal for this level of tech.
Yeah, and apparently you could even drop that another 10% with the checkout code 10% off.
It's just a prime example of incredibly sophisticated AV architecture becoming, commoditized. But, it also raises an important question about our broader tech ecosystem.
Oh, lay it on us.
Well, in an era where we are utterly obsessed with going entirely wireless, where we just expect pristine 4K streams to magically float through the air, Consider the sheer physical engineering still required to flawlessly move a single 4K signal just 130 feet.
Yeah, the physical reality of it.
Right, the complex voltage modulation, the thermal dissipation, the literal copper. What does a device like this Kramer receiver reveal about the hidden, highly engineered wired backbone that is actually keeping our so-called wireless world running?
Man, I love that. The next time you're enjoying a flawless, supposedly wireless 4K stream, just remember the silent aluminum boxes packed into the ceilings, crunching billions of voltage changes a second just to make it happen.